Hello my friends, I'm here today to talk about the new Blackmagic Raw format and the main advantage and why did the Blackmagic became with this format. Before that, the Blackmagic Raw was a sequence of DNG pictures, but the problem was that each picture did not contain the information about the sensor where this picture was taken. So it was a bunch of individual photographies in DNG RAW, but DaVinci resolved to deal with these frames, individual frames. He had a lot of work. The CPU, the GPU was always working, and now the Blackmagic came forward with a new format, the Blackmagic Raw. Just a quick explanation. Here we have a representation of a pixel. We have two, it's a Debayer sensor, two greens, one red, one blue. And if you see, each one has different percentage shown on this picture. For this example, we have maximum value 255 100% in the red channel. We have 1% in the blue channel. We have 91% in the green channel. And I want to know what color is this. If I have 100% of red, 91% of green, 2% of blue. And the answer is yellow. It's a yellow pixel. Yellow pixel. And why I'm talking about this? So this is the science of color. Very few people talk about this on this level. I will try to explain because I have some knowledge on this area. I will share it to you. So, if there was a yellow light hitting this pixel, the readings will be 100% on the red, 91% on the green, 2% on the blue, and on your computer you will see a yellow pixel. But between the sensor and the camera and the computer, there is no color. Yeah, that's right, there is no color. When the image go to the file, there's no color. What? No color? Yeah, your color cameras has no color. So this GH5, I'm recording this episode when the file is recorded to the SD card, it has no color. But we need to decode to do the Debayer, the demosaic. I will give you example for you to understand what I'm talking about. Imagine a place full of people, thousands of people. Imagine a football stadium, 60,000 people inside, and each people received this information, and each of the 60,000 people have different combinations. So the person number one has this combination, the person number two has another different combination, and all that combinations will give an image. Imagine a stadium full of people, and you want to know which color each person have. Before, you had to go to imagine each person. It's a DNG picture, and you want to know what inside that picture. So you go to the first person. What is your color? Oh, let me check. Oh, okay. I have these percentages. And you go to the second person. Oh, I have this one. Imagine what it takes. So it's like the CPU of the computer trying to understand what is inside of each picture. Now with the Blackmagic Raw, that game has changed a little bit. Now each person will listen for the question at the same time. Go to the speaker. Hi everybody, what color do you have on your combination? And everybody listens at once. So that is the main difference. Before, the CPU had to struggle to understand what is inside of each picture, and he has to repeat all over the same process, even though he fully understands what happened on the first picture, but on the second picture is all the same, but the CPU doesn't know, so he struggles to understand what is inside the second, the third, and the fourth. So before, when you shoot RAW on your Blackmagic, your CPU went crazy to understand all the DNG sequence each by each, one by one, and it takes a lot of computation, it takes a lot of time, and sometimes people prefer to record ProRes. It's lower space, faster encoding, and many people were not taking advantage of the RAW formats that you had on the Blackmagic cameras. But now, what Blackmagic do is, on the camera, the file that is being recorded has information about as part of the information about the sensor. When the image passes to the computer, he has to do the debayering, the mosaic, so he will read the levels and finish the image. But as the half work was done on the camera, your CPU knows everything. It will work less. For you to understand how the color is created, imagine this light meter. This light meter will read an amount of light, but on the sensor, each light meter has a color on the top, or a green, or a blue, or a red. And for now, when the image is created, between the camera, when you're recording a RAW file, before you decode the file, there is no color. There is only luma information. There's a luma information for this space, a luma information for this space, and a luma information for this space. And the computer needs to know, okay, I have 4 spaces, I have 4 luma values, but what is the color of each space? If the camera doesn't tell the CPU what is the filter on the top of each light receiver, the photodiode, the CPU will not know. Many of you, when we edit RAW photographs, when you didn't have the codec to read, to do the debayering of the sensor, you would end with a pink image, with a noisy image, because the CPU didn't know this space was blue, red, or green. Now the new Blackmagic RAW, the new file, will tell the CPU, hey, listen, on this luma value that you read of 2%, it was blue. Oh, I understand. On this space, the luma value that you read 100%, it was red. And on these two that you read 91%, it was green. And the CPU will say, thank you very much, camera. Now I know where is the space that corresponds to the blue, the red, and the green. And the camera says to the CPU, and don't work too much, because all the image that I will send to you, they are all the same. Oh, thanks God, thank you very much. Before I was struggling each image. I had to knew where was the blue, the red, the green. Now I know everything. Now I can speed up. Yes, you can speed up CPU. Now you know each image, what is the sequence. So that is the debayering process. Between the camera and the computer, there is no color, just luma information. But where? The CPU need to know where is the blue, the green, and the red. As you can see in here, the Blackmagic now introduces this Blackmagic Raw and give you the opportunity to do uncompressed and compressed. 3 for 1, 5 for 1, 8 for 1, 12 for 1. Now you are saying compressed. I don't like compressed. No, it's you have to compress. On the red cameras, all the red cameras compress the image, and they have this amazing image. All the image being registered on the SSD drives on the red cameras, they are compressed. So on the Blackmagic, there will be the possibility to choose constant bitrate. No matter what the image comes, more detail, less detail, the bitrate, the data stream will be the same. Or you probably will choose constant quality. On the constant quality, the data stream, the bitrate, may vary. If you are filming a white wall with a red square on it, the bitrate will lower. If you are filming some person moving on the street, trees, the ocean, a lot of detail, the data stream, the bitrate will rise. So the camera will put more or less bitrate depending on the sensor is seeing. If the sensor is seeing a lot of information, it rises the bitrate. If seeing less information, it lowers the bitrate. It's a simple process. Remember, between the camera and the computer, there is no color. You have to have a decoder. The decoder takes time to understand each picture. That's because this GH5 has the whole eye frame rate and as the long op. The whole eye, all the frames are encoded independently. The long op, it encodes a frame, and for several frames you will analyze and just encode what is different between them, and after it will encode another frame, and after it will invent or encode only what is different. That is called long op, long group of pictures. For the whole eye, each frame is encoded, the next one is encoded. It takes more data, but it's better. For the Blackmagic Raw, they told that he will introduce this new codec, Blackmagic Raw, even to the newest Blackmagic Pocket Cinema Camera 4K. This will save space on your drives. It will speed up the processing on your computer. It will increase quality. It will increase your ability to do it faster and better. If you have some questions, I will be able to answer them. Thank you for watching. If you like this episode, subscribe. If you'd like to know more about the debayering process, how the image is created, I'm glad to help and to answer for all your questions. Thank you very much.